this video we're going to be talking about parallelograms, starting with the archetypical photo depiction of a parallelogram, this right here. The only requirement for a figure to be a parallelogram actually is that it has two sets of parallel lines, and also that it is also quadrilateral, which means that it has four edges. And so this is the regular depiction of a parallelogram, which looks like this. So this is parallelogram. But it is also not very controversial in the mathematical community to say that these figures over here are also parallelograms. So this down here is a rhombus. It is representing all the rhombi in the world. So a rhombus has four sets of congruent sides. So I made a mark right here to say that all four of these sides are congruent. You'll notice in the parallelogram that I have up here, there are only two sets of congruent sides. So it's this side and this side, and this side and this side. Next figure we have coming up is a rectangle. Rectangle is also a parallelogram, but one stipulation, one very important requirement is that all of its angles are 90 degrees. And you'll notice that, like a parallelogram, it has two congruent sides up here and down here, and two congruent sides from the left to the right. And then finally, we have our square, which is much like a rectangle, except all four sides are congruent, like a rhombus. So it also has 90-degree angles here. And if I were to draw their family tree of sorts, so I would have like okay, well I have a rhombus up here. Oh, they usually draw circles for these things, right? So I have a rhombus in this big circle. These are all the rhombuses, rhombi. Oh, sorry, not rhombi. Trapezoid. So I have trapezoid in the big circle. Trapezoid. And then side trapezoid are all of the parallelograms, although I'll say that this is kind of based off our definition of what a trapezoid is. Some mathematical texts define it differently, I believe. Anyways, parallelogram. And inside of parallelograms, we have rectangles, and we have rhombuses, rhombi. And squares are kind of, I suppose you can say the outlier, because squares, all squares are rectangles, but all squares are also rhombuses. So, okay, I guess I would have to maybe they, squares, SQ. Anyways, that's where squares go. Besides these two properties, actually, because of these two properties, there are loads of other properties that also show up about parallelograms. For example, it has congruent, opposite angles are congruent. So these two angles are congruent, and these two angles are congruent. And that is because of something else we discussed before, when we had parallel lines and a transversal. So when we have parallel lines and a transversal, like those are these parallel lines, we have congruent angles here, incongruent angles over here. Well, you can kind of apply the same logic to our parallelogram right here, right? So our parallelogram is actually just composed of two sets of parallel lines. So if you if you want to try to draw our parallelogram and then, apply these same rules, you'll see that, oh, it's kind of getting messy, and I made a mistake. You'll see that our properties show that in a parallelogram, opposite sides are congruent, right over here. A little bit small, I'm not quite sure if you guys can see it, but there it is. Another property of parallelograms is that when you have two diagonals. So you draw this line here, and you draw this line here. When you have two diagonals, they bisect each other. So what it means when they bisect each other is that these two lines created are congruent, and these two lines created are also congruent. And so that's mainly because, and we can prove this actually, but I won't do this here. It's mainly because we have also congruent triangles created when we make these two diagonals. So these two triangles are congruent, and these two triangles are also congruent. And you'll notice that when we have this rectangle over here, and we draw our triangles, it's a lot more clear that these two triangles are congruent and these two triangles are congruent, which also, you know, makes this true. Except in the case of a rectangle, actually, all of these lines are congruent because of, you know, its properties. And for the square, that is also true. I can draw the lines again. For the rhombus, it's much like a parallelogram, so all the sides are the same. So the angles are different. So these two lines, you can only say that these two lines are congruent and these two lines are congruent. What else is there about parallelograms? Oh yes, how to find the area of a parallelogram. So the general formula, and the one that you use for rectangles and squares, and you can also apply to rhombi, is that the area is equal to the base times the height. So if you have, you know, I'll do this with a rhombus actually, because it's not extremely intuitive when you have rhombus up here. Here's our rhombus. Here is our base. You have to, you should know that this is not the height. This here is the height. So if you multiply the base times the height, you'll get the area of the rhombus. Works with parallelograms too. In the case of some figures, like the square, for example, you'll notice that when we draw our marker, when we draw our diagonal, you actually create 90-degree angles. So they only give you the dimension of one diagonal, and you should know that the other diagonal is the same dimension. Let's say that it's like 3 cm. You can figure out the area of the square because it cuts all of these into right triangles, right? So you would multiply diagonal times the diagonal, and when you do that, you would create a figure that kind of looks like, you would find the area of this kind of shape. This is not a great drawing. But you would find the area of this kind of shape. Then you would divide by 2, so you get 9/2. And that would be the area of the square. Because, well, the square is just made of a bunch of triangles. You can also do this with other figures, but it is a little bit more complicated when you don't have 90-degree triangles. But, you know, in the case of a rectangle, you can create 90-degree triangles like this. So now you have a 90 degree, now you have a 90 degree, and you have more 90 degrees, right? So you can split up like this to get your 90-degree triangles. For parallelograms and rhombi, I would not advise this method. I would try my best to get the base and the height to get the area. Anyways, this has kind of been me rambling about geometry, but I swear if you get an intuitive feel for all these shapes, you'll see how helpful it is in geometry problems. Thank you guys for watching. Our next video will be about kites.